In this video, I wanted to go over how to calculate parallel resistor values for RT, and I'm going to show you a couple different ways of doing that using this TI-30X calculator. You have these calculators supplied with your toolbox. One thing, just real quick, with this calculator that can be a little bit problematic, if you try to turn it on and it doesn't come on, check and make sure that none of the keys are kind of stuck. I found that sometimes these buttons get stuck, and just make sure that they're not. And otherwise, the calculator should work fine. Okay, so I've drawn a parallel circuit here with R1 and R2, a 1K resistor, and a 2.2K resistor. And what we're trying to find is the total resistance between these 2 points. Now, sometimes in circuits it's shown over here, where we could be looking at R sub T on the end, or at the end nodes here. The important point when we're looking at parallel circuits is making sure that there's a single connection point between the bottom and the tops of the resistors, uninterrupted. And that's basically how we define a parallel circuit. So to calculate this, there are a couple of ways, there are a couple of formulas that we can use. And let me write these out. So if we just have two resistors in the circuit, there's kind of a simple way of doing this called product over sum, where we multiply R1 times R2 and divide it by R1 plus R2. The order of operation here is important. So if we're going to do this on the calculator, we take 1,000 times the value of the second one, 2,200, divided by, and then I'm going to put this in parentheses. And the reason why is that if we don't have the sum of these that it's divided by, you can have an error. So then we're going to have 1,000 plus 2,200, close the parentheses and hit equal. And we end up with a value here of 687.5 ohms. And with parallel circuits, the important thing to remember is that the value of the total parallel resistance is always going to be less than the smaller resistor value. So this is under 1K. So that's a reasonable answer. In fact, if this was exactly 2K and this was 1K, this value would be 2/3 of the smaller value. That's just how the calculations turn out. Now let me show you the other method to do this. Okay, the other method that I'm going to use to show you how we can do this calculation is using this reciprocal formula. 1 over RT equals 1 over R1 plus 1 over R2. And at first this may seem a little bit more complicated, but once you learn how to do it, it's actually a lot easier. And one of the reasons why this formula tends to be a little bit better is that if we have more than two resistors in parallel, that previous formula doesn't work. It has to be modified and it gets a lot more complicated. The nice thing about this formula is you can actually have multiple resistors in parallel, and it makes it a lot easier to calculate it. So let's see how this works. I'm going to plug in the first value, 1,000 ohms here, 1000, and I'm going to press the 1 over X button, and that gives me this value of 0.001. Then I'm going to add 1 over R2, so I'm going to take 2,200, 1 over X, and we end up with this really small value, 0.00145. And now that is not the final answer, and that's important because that wouldn't be reasonable. We know that it should be in the hundreds of ohms. It wouldn't be this tiny, tiny value. So to calculate this, what we've really calculated here is 1 over RT. To find the actual final value, what we do is hit the 1 over X button again. And then we end up with the same answer, 687.5 ohms. What's important here, of course, is that you keep track if there are Ks, that means thousands, or 10,000s. You want to make sure you use the proper orders of magnitude. So this works really well. I just wanted to go over that. So if you have questions on that, let me know. But let me do that one more time so you can kind of follow the key steps on that, or the button presses. So we have 1,000. We're going to take 1 over X plus 2,200, 1 over X equals, and then we're going to hit 1 over X one more time to get our final value.